Welcome to Accounting Modeling. In the today's video, we are going to discuss about another important capability that is available in your spreadsheet package. We call it sensitivity analysis. In order to perform sensitivity analysis, certain tools are available in your spreadsheet package. Here we are going to discuss about three important tools that is available in your spreadsheet package to perform sensitivity analysis. Under this topic, we expect to discuss about the data tables. So when come to the data tables, there are two variations of the data table. We call it one-way data table and two-way data table. The second important tool that is available, we call it the goal seek command. And finally, we are going to looking at the scenario manager. So this would be the three main tools that is available in your spreadsheet package to perform sensitivity analysis. First, we'll start with data tables. The sensitivity analysis, this is another area that you are comfortable from your prior learnings. You would be comfortable in sensitivity analysis. So especially when you are learning uh, your management accounting courses in the second year, there you have exposed yourself to a certain extent to this sensitivity analysis. So if you look at what this sensitivity analysis means, it is simply shows the change in a particular output. So it will show a change in a particular output in response to a change in an input. So that is simply what we call the sensitivity analysis. When there is a change in the input of a model, so what would be the changes that it brings to the output? So that's what the sensitivity analysis. So if I want to take an example for this, under this course we have discussed about the NPV. We have discussed about the investment appraisal and there we worked out NPV of a particular project, of a particular investment. We have discussed the NPV. So we have worked out the NPV. So in that, we have used different inputs. For example, you have used the initial investment and you have used the cost of capital. So sales price, variable cost, likewise different inputs were used. In that, let's say for an example, so you want to see how a particular output or how this NPV change when the given cost of capital is changed. In fact, you have tried that by using your knowledge on different buttons, even by using that. So you have changed this cost of capital figure and see what is the change that it brought in this particular NPV. Similarly, you could have changed any of these variables and see what is the effect that it is there. So in fact, you don't have to confine to a one input. Even simultaneously, you can change several inputs and you could have seen what is the impact that it brings in. For an example, simultaneously, you can change the sales price, the variable cost, and also the cost of capital and the what do you call that, the corporate tax rate. So having changed them simultaneously, having changed several inputs, you could see what is the effect that it brings to the output. So in our case, it is your NPV. So it is possible. So basically the sensitivity analysis means when there is a change in the input or inputs, what is the corresponding change that it brings in the model output, or even it may be outputs, output or outputs. It is what we call the sensitivity analysis. And again, if I am to take another example, even you have worked out the depreciation schedules. Depreciation schedules you had worked out. So in that also, you could have changed one or two variables and could have seen what is the change that it brings in to the depreciation of a particular under a particular depreciation method. Say that you would have make use of the straight line depreciation method. In that, if you had changed the useful life and the residual value estimate, you can see what is the impact that it brings in, or what is the impact that it reflects in the annual depreciation. So it is another example for this sensitivity analysis. Similarly, you can think of the loan amortization schedule. There you could also see when you change the given inputs like the period of the loan and the underlying interest rate of the loan. So once you change this input, what is the effect that it has on the monthly installment or annual installment? So this is what we call the sensitivity analysis. Now we may look at how to perform this sensitivity analysis using the capabilities that is available in your spreadsheet package. We are going to first look at the data tables. That is an important tool which helps you to perform a sensitivity analysis. Under these data tables, basically two types of data tables are available. As I mentioned earlier, one-way data table and two-way data table. And let's see what those are and what are the similarities and what are the changes in between this one-way data table and two-way data table. Let's start with one-way data table. In one-way data table, you can read here to have any number of outputs by changing one input. What you can do using the one-way data table is the one-way data table will help you to see what is the impact that it has on a particular output or outputs by changing only one input, right? The only thing that you can do is when it comes to the inputs, you can have only one input. You can see when you change one input of a given model, what is the effect that it has on the output, or it may be output. It doesn't matter. It doesn't matter, right? You can check any number of outputs, but the only thing is you can see the effect, the changing effect of one input. By changing one input, you can see what is the effect on the output or outputs. But in contrast, when it comes to a two-way data table, that will allow you to check the impact of two inputs simultaneously. It is simply an extension of the one-way data table. So it eliminates one of the limitations that is there in one-way data table. In one-way data table, you may have to confine to a one input. By changing one input, what is the effect that it has on the output or outputs of the model? But in a two-way data table, you can simultaneously change two inputs and see what is the effect that it has on the output or outputs. So that is what the two-way data table. Having exposed yourself to these different types of tools, when you are given a particular scenario, particular business scenario, you have to decide what must be the suitable data table that I would have to use. It may be sometimes the one-way data table, or it may be the two-way data table. So it's your judgment. You have to decide, given the business scenario, what must be the tool that you should come up with, right? So it could be one way or it could be two-way data table. Let's first see how we are going to use this one-way data table. Here we have list down the steps what it takes to use this one-way data table. You can see that first it says you need to develop your model. The starting point is always you need to work out the model by identifying the suitable inputs and outputs, develop the model. It could be, say, the investment appraisal. Then first what you need to do, you need to identify the inputs of the model and then work out the output. Then better work out the output and arrive at the NPV. So that is the very first thing. Thereafter, you can make arrangement to check the change in a particular input and how it reflect in the output. Having developed this model, as the second step, what you have to do is you may have to list input values in one column. Let's say that now you are going to check when the cost of capital of the project change, what must be the NPV? Say that is what you are going to check. When you are going to change the cost of capital, then what must be the effect that it has on the NPV? So what are the corresponding NPV values for this different cost of sales? So that's what you may test, right? So you would take this input, that is in the sense cost of capital, listed in a particular column, right? So you may go to a particular column and you start, say, cost of capital is 10%, 11%, 12%, 13%. Likewise, you may simply list them down. Then it says, move over one column and up one row. Then your expectation is to see the effect on the output. So therefore, now you have to move to the next column. And it says that you have to go one row up, right? So just to show you this, then it would be more convinced, right? It's like this. If I take an Excel, let's say that you have a model that is developed in your hand. So let's say that it's a NPV. So here you may identify the cost of capital like this. It's 10%, 11%. So let's say that the incremental change is 1%. Then you can simply make that particular change like this, right? So it's like this. Now let me drag this up to several numbers. Let me take it up to 25%, right? So these are the cost of capital figures. Now you have list them down in a particular column. In a particular column, you have list them down, right? Now what you are going to do, so this is basically your input, no? This is basically your input. Then you want to see the effect that it has on the output. So your output has to be what? The NPV. So there you have to refer to the basic model what you had worked out. Here I do not have a kind of developed model. So therefore, let me just assume a particular cell to be the output. Let's say this is the NPV1. This particular cell, that is B11 cell, shows the NPV, let's say. Then you have to come to this output and specify that and give a reference to the NPV. That's what it says. You have to move over one column and up one row and specify the basic model output there. Right? That must be the second step. That must be the thing what you have to do next, right? Then what you can do, then you can select the data set. So when you are selecting that, make sure that you take all the inputs and also the output. So therefore, when you are selecting that, make sure that your selection, the range should cover the output. So that is the NPV, which you have placed one row up, and all the inputs. So in that you have to make this selection like this. Then you can go to, as it says, you need to go to data tab. So you need to go to data tab, and then under the forecast you can see that what if analysis is there. So if you simply click the drop down menu, then you can see that different things are available: scenario manager, goal C, and data table. So this time we are going to get the data table, right? You may get the data table next. Then you will be directed to this particular kind of data table, this particular kind of dialog box. In that, so the two questions you have to address: the row input cell and column input cell. So here you are using one-way data table, and also you have arranged the things in column, right? You can see that here you have make use of the column G and column H. Hence, this time the column input cell is what is relevant. Then you may go to this column input cell, and you need to specify what is the column input cell. What is the column input cell? And what is the output, what is the input of this particular model? In order to do that, you may have to go to this input section. In the input section, you need to identify the cost of capital. Right? You need to specify that. So then let me specify that. Say in our case, that is B4 is the cost of capital, let's say. So you have to specify that and say OK, right? The B4, let me say that is the cost of capital. So this is the cell what I have selected. So once you select that, then all the outputs are given in relation to the inputs that you had specified. If the cost of capital is 10%, what is the output? If it is 11%, what is the output? Likewise, it would be specified. So you don't have to do, it's just a selection of few cells. You have specified the output over here, and you have specified the cost of capital cell, and then the required output was delivered, right? Now let's work this out using a particular example, then it would be more convinced, right? So let us take a kind of simple model and see whether it works, right? Okay, let's say that you are taking a business scenario that is relating to a introduction of a new product. So you are going to introduce a new product to the market. In that, say you have identified some of the useful piece of information to your model, right? So let's say that the inputs, we may take the inputs, right? Say selling price is a must. You identify the selling price, say it's 150. So you have found that this particular good can be introduced to the market for 150. The variable cost of that particular product, say that you may purchase it from outside and sell it. So that could be a kind of outsourcing model you may adapt. Say you can purchase them for rupees 60. Then some kind of fixed cost is involved in your business organization. You may have to pay the rent, and the depreciation is also there. Hence, some fixed cost is there. Say the fixed cost is like 500,000 at the moment. Per month, 500,000. Then by using this information, you can work out the output of the model. You can work out some output. Say that you want to get it into the profit figure. You want to get it into the profit figure, right? So we need one useful piece of information which I have forget. So it's about the demand has to be there, no? Demand or output, right? Demand. Let me say the expected demand. Say it's like 10,000 units. Let me assume 10,000 units. Now let's work out the profit for this given scenario. So how do? You can simply take the sales price minus the variable cost, that is the contribution, right? And multiply this by the number of units. It gives you the total contribution. And once you deduct the fixed cost from this, and it will give you the profit or loss. So accordingly, if 10,000 demand exists in the market, your profit is going to be 400,000. Your profit is going to be 400,000, right? So this is what the basic model. So assuming a particular business scenario of new product launch, you had worked out a particular model. Now you can change the variables and see whether it works. So it perfectly works, right? If you make it 100, yes, it works. But let me stick to the basic model now. Now I want to evaluate that because this is a kind of forecast, right? This is a kind of expected state. You have expected these factors to be there. Then what you can do is, there's a risk. The risk involved, you do not know. So what will happen to the sales price? So the sales price can vary in the market. So it can be changed. So you may have to respond accordingly. So the similar product would be sold in the market at different values. So accordingly, you may have to respond to that. So sometimes your plans has to be changed. Originally you thought of selling it at 150, but sometimes you may have to sell them at like 120. So depending on the competition in the market. So likewise, depending on the environment that it exists, so you may have to respond. Accordingly, what you thought of? You thought of carrying out a sensitivity analysis. You want to see what would be the output, what would be your profit figure under different selling prices. So under different selling prices, you want to check what is your output, what is your profit. Say that you are going to start it from rupee 100. So what if the selling price is 100 and that is your starting point. Then you thought of changing this price from rupees 10. You are assuming that what if price is 110, 120 likewise, right? Then I have assumed that the incremental change is 10. So I'm going to derive several, right? So I have taken up to 220. Let me take up to 200. Okay. Now I believe in the market, a similar product would range from rupee 100 to 200. Under these different circumstances, under these different sales prices, what would be my profit? That's what you want to see. So here you have identified the input, that is your sales price. Then when you are going to initially perform this one-way data table, you have to do it according to a particular way. You must first list down your input in a particular column, right? Then you have to move over another column and up one row and place your output. So make sure that you are giving it with a reference. Make sure to give it with a reference, so it's equal 400,000. You make that reference, and this is your profit. You can simply have a note on that. That is your output. Now what you are going to do, when the sales price change, what is the effect that it has on the profit? You are going to check that. That's what you are going to do. So in order to see the output, you can see, select the entire range, including all the inputs and also the output. Then you have to go to data, as we did earlier. Then what if analysis, then try out the goal seek. Try out the goal seek. Sorry, try out the data table, right? In the data table, there it asks you the question. So you need to give these inputs. Is it row input cell or column input cell? So here, since the things have arranged in columns, you have to specify the column input cell. You can see that the arrangement that is in columns, the column F and column G. Hence, the column input cell is going to be there, not the row input cell. Then you may specify that. And how do you specify? You need to go to the input of the basic model and select what is your input. Here you have select the sales price as your input. So select the sales price of the basic model and say OK. With that, you can see this would be the different outcomes, right? So if your sales price is 100, if the demand exists at 10,000 level and the variable cost is at 60, so it's going to be minus 100,000. 110, it's 0. 120, 100,000. Likewise. So in order to verify yourself, see at 150 you can see it's 400. So therefore you can verify yourself that you have performed the things correctly. So it is the verification. So here what you did, you simply change one input, that is selling price, and see what is the effect that it has on the profit. That's what you had worked out. Similarly, when it comes to this arrangement, it is always need not to arrange the things in the columns. If you wish, even you can arrange the things in the rows even. Let us try that as well. Say that you are going to take this input, that sales price, somewhere over here, starting from 100 as usual, and the incremental change, let me say it's 10 rupees, 10 rupee change. Then let me drag it, can change, take it up to 200, let's just take. So as usual, right? Okay. Now you are going to take your output, it is the profit. Now you have to, like you move over one column here, now you have to move over one row. Then take it, move over, and you need to come one column ahead, and in that you are going to place your output. So it is profit. Say OK. Now as usual, you need to select the range which includes all the inputs and the output. Having selected that, you can go to the data, what if analysis, come to the data table, and this time what you have, is it column input or row input? It is exactly the row input. Now you have made the things arranged in rows. Hence, this time you would be having row input cell. And what is your input? It is sales price. Say OK. See, the same output you have arrived. The same output you have arrived. So accordingly, It's something up to you. When you are using the one-way data table, you can arrange the things in columns, or you can either arrange them in rows. But this is the fundamental thing what you need to ensure. The first develop the basic model, then structure the output, and accordingly place your inputs and also get the output to the necessary cell and select that and apply the data table. So this is how we perform the one-way data table. Here we have given one activity. So I believe that now you can manage this activity. But so just to discuss that, the Fernando Enterprises has gathered following information relevant to a particular product that it plans to produce in the next month. The variable cost is identified, rupees 35, fixed cost, rupees 300,000, and the demand 10,000 units per month. However, if the price of the product is greater than or equal 130, the demand will come down to 7,500. So they have identified that, they have observed the market and found that. So the maximum, so if you exceed 130, you cannot achieve the demand 10,000. So your demand would come down to 7,500. But if the price is less than 130, yes, 10,000 demand could be achieved. The marketing team has found that the marketing prices for a similar product are ranging from 100 to 150. Fernando Enterprise want to do a sensitivity analysis for the entire price range is rupees 5 incremental basis. So now you want to perform a kind of sensitivity analysis and see if this price varies from rupees 5 each for different combinations, so different prices, what would be the profit that the Fernando Enterprises would likely to encounter. So here it's a kind of business scenario. Now we may take this information and let's put that it is something similar to what we have just discussed, but so we may try this out and see. Having taken the given information, the very first thing, as usual, identify the inputs. Identification of inputs is the most important thing in a model development. To start with the selling price, you need to get into variable cost. It's given to be 35 and the fixed cost is there. Fixed cost is given to be like 300,000 per month, and also the demand information is given. Demand information was given to be 10,000 basically. Then you need to get your output. Your output is going to be the profit. Profit is the output. Here, working out the selling price is little tricky. It says that if the price of the product is greater than 130, the demand will come down to 7,500. If the price is less than 130, the expected demand could be achieved. So it's not in fact the selling price, but the demand could be the tricky one, right? So let's take a basic sales price, say 100. You need to work out this demand. You cannot take this demand like 10,000 here, but instead you may have to make use of your knowledge in if functions and get this demand, right? So let me take a basic if function. You're going to say that if the sales price is greater than or equal 130, what happens to your demand? Your demand becomes 7,500. If not, that is in the sense it is less than 130. The demand is going to be 10,000. Yes, you managed to get that. Now you can try this, say it's 140. Yes, you can see the demand respond. So if it is 120, Yes, demand response, right? Okay, now you can work out the basic profit. So always the selling price minus, sorry, you can make the reference, you have to make the reference for sure, otherwise uh, the one-way data table is not going to work, because everything depends on the relationships that you would specify. So therefore use the references. Contribution per unit into the demand, total contribution minus the fixed cost. So there it comes, the profit 550,000. 550,000. Now you have worked out the basic model. Now you can try out the one-way data table. The input is going to be the sales price. It ranges from 100. Incremental change is like 5%. So it ranges from 100 to like 150. So a similar product. So therefore let us try it up until 150. Then take your output. What about the output? It's profit. You can specify that and have it. Select the entire range, go to the data, what if analysis, data table. Now you have made the arrangement in columns. So column input cell, it is sales price. And this would be the different outcomes that it generate, the different profit figures. So you can see the different profit figures that it has generated. Then you better see what is the highest profit figure that you can arrive at. So you can ask the highlighting, see the highlight. You can say you want to get the most the price that gives you the highest profit. It is price 125. So if you get the price 125, if you stick to the 125 under the conditions, the existing conditions of variable cost and fixed cost and the demand, you would likely to generate a profit of 600,000. Hence, it seems that the best price could be that you can set is going to be the 125. So that is how this sensitivity analysis would help you practically. So you can think of what may be the optimum input that you should stick to. So it will help you with that, right? So it's about the one-way data table. Now let's look at a simple extension of that. It's about the two-way data table. The two-way data table is quite similar. It's a simple extension, as I mentioned. The very first thing what you need to do, you need to have your model in hand. You need to have your model in hand. Thereafter, you may arrange the structure as you did in case of one-way data table. So you have to arrange that structure, but here, so you have to do a particular thing, because you need to specify your row input as well as column input. It has to be specified. So hence the structure what you would develop would be little different from the structure that you had taken under the one-way data table. So let me show you how do you structure this two-way data table. So let me get it into the first example what I had taken. So here we have the sales price, demand, variable cost and fixed cost information, and we have worked out the profit. So if I take the same example, let's say that this time the question or the business scenario says that you want to see when two variables change, the sales price change and simultaneously variable cost tend to change. So if there is a change in both this variable, what is the effect that it has on the profit. That's one thing that you can check using the two-way data table, right? Then you have your basic model developed on hand. Now you are going to structure the output. Let's take, as usual, let me take sales price. Sales price in one axis, it is starting from, let's say, 100, and it change incrementally 10. 100, 110. Likewise, it would go up to 100. Let me have some space for this. Right, let's say it goes from up to 200, right? It takes up to 200. And this is your one variable. So it is in fact the column input. Since you are looking at two variables, you need to place the second variable in that. And how do you place the second variable? So obviously it has to be placed in a row, right? Now you have placed one variable in column, and now you are going to place your second variable, that is variable cost. I would say the variable cost in the second, as the second input. So let's say that it ranged from 50, incremental change, say 5, right? Then I'll be arranging it like this. Let us take that up to 90, right? Okay, now this is the structure that you have to get done before you are performing two-way data table. So the first, you must take one input to the column and the second input to the row, and there must be a kind of a space over here, and in that particular space you are getting your output, you are getting the model output there, right? Then say 100,000. This is what the structure that you should develop for the two-way data table. Take one variable, take one input in the column, the other variable, other input in the row. Then you need to place it in the location where I have kept that. So at the starting point of both the inputs, and then you can select the entire range, and then you can go to the data, what if analysis, data table. Now you have the answers for both the question. The row input cell, what is that? In the row, what you have arranged the variable cost. In the column, what you have arranged, the sales price. Say okay, this is it. You can see for different combinations, the profit figure, the desired profit figure has been derived. So again, similarly, you can identify what would be the highest values, highest profits. What would be the feasible combination? Let's say that you want to have the top 10, and this gives you the top 10 combination. The sales price 180 and variable cost 50. Sales price 200, variable cost 75. Likewise, different combinations that is feasible are given. Now let's read and see whether it makes sense, the two-way data table. First, you need to develop the model, as I mentioned. That's the starting point. Then you need to list the values of one input in the first column of the table range. So you have taken one input to this, one input placed in the column. And then list the values of the other input in the first row of the table range. So then you have placed the other input in the row. So keeping some space over here. right, leaving some space. And then formula for the output must be placed in the upper left corner of the table range. The most important thing is placing your output. The output has to be placed in the upper left corner. The upper left corner, you have to place the output. And that would be the structure. Then you can select the table range as we did and perform the data table. It's two-way data table, right? Okay, now let's look at the activity, then it would be more convinced. Let's move on to activity 2. The activity 2 says that with reference to the activity 1 above, suppose Fernando Enterprises want to determine how annual profit varies as price varies from 110 to 170, incremental change is 10, and unit variable cost varies from 35 to 50, incremental change 2.5. Now Mr. Fernando wants to see what is the impact that it has on when there is a change in two inputs. When there's a change in two inputs, what is the effect that it has on the output profit? Determine the optimum mix of price and variable cost. Let's see what would be the optimum mix. So accordingly, you can see, again, let me take this question, the activity 2. So let's identify the two inputs, right? The two-way data table, starting from in one column. You can take one input in a column. So its question had said that it varies from like 110 to 170. Okay, it starts from 110. The incremental change is like 10%, not 10%, 10. So you can take it up until 170. So that is your one input. The second input is, it's going to be the variable cost. They want to have it from 35. So 35, the incremental change 2.5, 37.5. So you may drag it up to 50, right? Now most importantly, you need to place your output in the upper left corner. Upper left corner equal the output of the model that you had developed. So it's 600,000, right? Now you can select the entire thing and go to the data ribbon and the what if analysis data table. Specify the row input cell and column input cell. Row. In the row you have arranged the variable cost. Go to the basic model and give the reference. And the column input cell, so go to the basic model and select what is the column. It is sales price. Say OK. So once you do so, you can see that it got filled. So it's just a matter of few clicks. So if you are supposed to do that manually, yes, in fact, you can try that, but you cannot take different combination like this, no? Say that you want to work out combination like 35 and let's say that you want to take a combination of like 120 and 40. Yes, that particular combination can be get, but the thing is, at one time you can see only one input. But here the advantage is that you can see different combination at the same time. At the same time you can see different combination. So that is the advantage what you would have in using a two-way data table and even the one-way data table. So here you've been asked to work out the optimum combination. Go to the conditional formatting, top row, highlight the top one. It's 712, 500. It's 712, 500 is going to be the optimum combination. So it's 35 variable cost, the selling price 170, it gives you the highest profit peak. Right. Now let's see another example for this, that is activity 3. So a comprehensive example. Let's see, right? Mr. Ferreira needs rupees 1 million to construct his home. He is planning to borrow a loan from a bank to cover either the full amount or part of the amount from the bank. He is approaching a bank with the intention of taking the entire 1 million if possible, or it may be something below than that. Because the constraints are there, we'll see the Mr. Ferreira can afford only rupees 20,000 monthly payment as the loan installment. So that is the constraint, right? He would like to take even 1 million, but the only thing he can pay on a monthly maximum of 20,000. So that is a constraint what Mr. Pereira is in. There are 5 loan schemes based on the loan period. So the bank has offered Mr. Pereira 5 loan schemes. The loan goes as the plan A, B, C, D and E. And in each of these plans, you can see that they have specified the maximum period that they can go. So the plan E is designed like for 24 months. The plan B, it is for 36 months. C, 48 months. Likewise, they have several plans available with the bank. So it has been offered to Mr. Perry. Then also the annual interest rate is given. The annual interest rate is determined as follows. If you go up to 850,000, the interest rate of 12.5 can be offered. Under any of these plans, if you go up to like 850,000, 12.5. 850,000 to 1 million, 13%. And more than 1 million, so it would be like 13.5. So that is the situation what we have. So they have given a kind of annual interest rate. Further it says that, however, for increase of every 12 months from plan A onwards, an additional 0.5% should be added to the base interest rate in the above table. So here what you've been offered, what Mr. Pereira has offered is a kind of basic interest. If he would settle with plan A, he would be eligible for that. If he would settle with plan A, then depending on the amounts that he would borrow, he can get settled with this rate. But if he is changing the plan, so if he is settling for a plan other than plan A, then there would be a kind of additional interest applicable. And that's how this bank loan comes. No? So they give this interest rate and they tend to put a kind of star mark there. No? Then they will give it like it comes with condition, and this could be a condition. This could be a condition, right? They would initially say, they would give the impression that this would be the interest that we would charge from the customers. But it comes at a kind of condition. If the customer settle with plan A, yes, we are ready to offer this interest. But if it is a plan other than A, then this would be the case. For every 12-month increase, so originally you were allowed to go for 24 months. So if you go for 36 months, 0.5% must be added to this interest. If it is C, then it's going to be 1%. If it is D, 1.5. If it is E, 2%. Likewise. So that's how the things would work. So you need to consider each and every condition and develop a sensitivity analysis to find out the feasible combination of loan plan and amount. See what are the feasible loans for Mr. Pereira. So you need to take your inputs as the loan plan, the period, and also the amounts. So by taking different combination, work out the most feasible combination for Mr. Pereira. So that's what the question is about. So let's copy this information first and let's work this out. Okay, so we have the basic information with us. Let's extract some useful piece of information, because our starting point is always working out the basic model. Hence, input has to be there, inputs, and also the output must be there. Output must be there, right? So it would be the installment, the monthly installment. Monthly installment has to be there. Then the input. So when come to the input, you need to have the loan period. So you need to have the loan amount must be there. Let's identify that. And also the period should be there. And most importantly, you need to have the interest rate. But when working out the interest, you need to consider about two things, because the base interest is there, the base interest, and also some additional interest is there. Base interest, and also there can be a kind of additional interest. Then as a matter of that, you can get the applicable interest. Applicable interest rate. So this would be the input that you need to first identify. Thereby the output must be worked out. Then we can move and work out the different combinations that is feasible for Mr. Pereira. Then what are the amounts that is there? So let's just assume a particular amount. Say it's 600,000 that Mr. Pereira wants to take. Then the period, so let's assume a particular period. You can only settle with 24, 36, 48, 60 or 72 months. That's what you can settle with. So say, let me say that it is 36 initially, right? Then what about the base interest rate? When it comes to the base interest rate, it depends on the amount. So therefore you need to get an if function for that and arrive at the base interest. You can see that the base interest goes like, if you go up to 850,000, it's 12.5. From 850 to 1 million, it's 13%, and more than 1 million, it is 13.5, right? Let us take that it's equal, then you can get an if function. If, right? The logical test is, if this particular amount is less than or equal 850,000, what must be the value? It's 12.5, 12.5%, right? As the question gives. Then if false, you need to check another condition. So make sure to take another if. So it's nested if application, right? Then you have to check whether it is less than or equal 1 million. If it is less than or equal 1 million, you can take 13%. You can take 13%. Value if false, then it must be something other than that. So it should be 13.5. 5%, right? That is it. That's it. Say okay. See, the interest rate has comes as 12.5. So if you change this amount, let's say that it is 900,000. Yes, 13% comes. If it is more than 1%, like 1.2 million, yes, it works. Hence, the nested if what we had developed to work out the base interest, that is perfectly fine. Let me get into the basic number 600, right? Now we may work out the additional interest. So when you are working out the additional interest, so you need to consider about the period. So you can see that. So here it says every deviation of 12 months from plan A. So you would likely to see that an additional 0.5% would be added to the base interest. So accordingly, you need to make use of nested if again, that is to work out the additional interest. Let's see. You would take if, then initially you are going to check if this particular period is equal to 24, then no problem. It's 0% would be there, no additional interest rate. But however, if this is like 36, then there would be addition. It's a 12-month deviation. So the corresponding interest rate change should be 0.5%. 0.5%. Then if false, you need to try out another if. If it is like 48, then it has to be like 1%. It should be 1%. Because you are deviating 24 months. For every 12 months, it's 0.5. So consequently, it's 1%. So you need to try another if. It's like if this is equal to like 60, then it's like 1.5. 1.5%. The value be false, so in maximum what it can put over there is going to be the 72, no? Because you are having a kind of fixed period. It would be either 24, 36, 48, 60 or 72. So then you can simply give 2% there. So otherwise you can take another if and say it's for 72, and if it is other than that, say it's 0. So whatever, right? So let me take another if for that, and it is equal 72, then it has to be 2%. If it is other than that, we need not to take any, right? Say, so I'm taking a null value there, right? Say okay. Right, here it comes as 0.005. So let me convert that into a kind of rate. So let's make it 48. It's 1%, right? It perfectly works. If it is 60, it's 1.5. If it is 72, it's 2. Let's say it's 78 mistakenly. No, nothing comes over there. So it works perfectly. If it is 24, it's 0%. Yes, your model works perfectly, right? Okay. Now you can get the applicable interest rate. It's simply the summation of base interest and additional interest. So accordingly, the applicable interest rate is 13%, and it's an annual interest rate. Remember that. Now you have all the required information. Now you can simply work out the input. Now you can work out the output, the monthly installment. So you can make use of your knowledge on PMT function, and you can work the things out. The rate, it has to be the applicable interest rate, but make sure that you are converting that into 12. You are converting that into a monthly interest rate. So divide it by 12. NPR, no problem. The number of months are given. So you can take that. Present value, that would be the loan amount, take it. So the type of the loan, we assume that it is paid at the end of the period, and the future value, we assume it as 0. So therefore, this would be the only two required information, and you can say OK. So here we have worked out the monthly installment for the basic model. So you can change the things and see how it works. Yes, it works perfectly. You can change these different inputs, and see, yes, it works, right? Now you can help Mr. Pereira with the optimum plan, right? So when it comes to this plan, there we have to identify the question it had mentioned. You need to consider about the plan and the amount. So we may take some different loan combination, say the amounts, different amounts we may take, say starting from like 500,000, and take the incremental change of 50,000. So let us take several combination up to like 1 million, since the maximum Mr. Pereira would require is 1 million. So I might take that up to 1 million, its amount. And then here we have the plan. So you have only 6 plans, I believe. 1, 6, 1, 2, 3, 4, 5 plans are there. So the plans are concerned. The first one is for a kind of 24-month. Every plan would represent increase of 12 months. So therefore take the 12 as the incremental value. Then you can go up to, this would be the available plans, 24, 36, 48, 60 and 72, right? Now take the output that you had worked out. It's the monthly installment. Take it. Now you can select that and easily go and work out what must be the combination, what must be the loan combination. Data table, row input set. What is the row? In the rows you have arranged the amount. So go to the basic model and specify the amount. Column, that is basically the period. So get the period specified, right? You have arranged the period in the column. Say OK. Now there it shows the different combination, the feasible combination. Different combinations are there. Now out of that, what sounds good to Mr. Pereira is going to be something below than 20,000. The maximum he can afford is 20,000. So therefore something below 20,000 is what sounds good to Mr. Pereira. Hence we may go to the conditional formatting. So take the highlight cells. It is less than. It should be less than 20,000. So it should be less than 20,000 is what sounds good to Mr. Pereira. So it should be in fact it should be the greater than, because so if you specify the less than, then the higher number would come. These are the negative figures, so therefore we want to make sure that it's greater than, highlight cells, greater than 20,000. See, this could be the combination which would sound good to Mr. Pereira given the constraint. So he can go up to maximum of 20,000. So there is a chance that Mr. Pereira to go for like 900,000 under the plan A, B, C, D, E. Under the plan E, the Mr. Pereira can go up to 900,000. So only he would have to pay 19,030 cents 5 for the maximum monthly installment. Even if he can think of having like 950,000 even, so because it's a slight change represented, even 1 million sounds good to Mr. Pereira under this plan E. because only 1145 increment is there. So the Mr. Pereira can think of this different combination and he can get settled for a particular installment that is feasible to him, right? So, but given the constraint, the maximum amount that the Mr. Pereira can go is going to be 900,000. So it is below 20,000. It's below 20,000.